Hello, advanced algebra students, and welcome back to another video lesson where we continue to focus on trigonometry and the right triangle trigonometric functions. So the first day we looked all about Pythagorean theorem with right triangles. Yesterday we looked at how to set up the trigonomic functions based upon which angle we're at. Today we are taking it to the application of what trigonometry is really for, and that's to find the missing sides or the missing angles. Today we're just focusing on the missing sides of right triangles using this right triangle trigonometry. So how can we use SOHCAHTOA to help us find a hypotenuse if I only have one of the legs and an angle measure? All right, so really, there's a couple different ways that we can help and find sides, but it all depends upon the information that we are given. The first day we used Pythagorean theorem. Like, how do we know we can use it? Well, because we have two of the sides to a right triangle. 10 squared plus 12 squared would equal the hypotenuse squared, which was x squared. And so we can follow this pattern and setup to help us find the hypotenuse, but all because we already had two sides. What happens when we only have one side plus an angle measure, or an angle measure on one side? Well, we're going to use the SOHCAHTOA rules. We're going to use those rules today. And then there's actually some special unique triangles that we'll learn later on in this chapter as well. So let's go ahead and dig right into an example to show and walk through how this process actually works. In this example, this triangle, they want us to solve for both x and y. They want us to solve for x and y. The first thing that we probably should do is identify where is the angle measure that we have that we can use. Notice, obviously, they give us 63. So we're down here in this vertice, this corner of the triangle, because that's the angle measure they've given us. So let's label the different sides of the triangle based upon the SOHCAHTOA rules. What would we call y if 63 is our angle measure? That's our opposite leg. What would we call the x? That is our adjacent leg. And what would we call the 50? Therefore, that has to be our hypotenuse. All right, and it's all based upon where that angle is located. Opposite, adjacent, and hypotenuse. And that's important because it's going to tell us what to really use. All right, so let's start with x, just because it comes first in the variable, right? We're going to try and find x, and the only two pieces of information we have is that an angle measure is 63 and the hypotenuse is 50. So what trig function, if I'm going to find x, what trig function uses adjacent and hypotenuse? Right? C-A-H. So therefore, it's cosine. We're taking cosine of our angle measure equals the adjacent over the hypotenuse. And we're going to fill in what we know. Cosine of the angle, which in this case, they're telling us the angle is 63, equals the adjacent side, which is x, over the hypotenuse, which in this case is 50. Now, yesterday we learned that cosine of 63 is it's some random decimal. It's a decimal digit that we could calculate. If we're trying to get x by itself, right, I want to solve for x. I want to know what does x equal. I got to get rid of dividing by 50, which means I'm going to multiply both sides by 50. Or x equals 50 times the cosine of 63. Now, how might I calculate that? Well, this is where our Desmos calculator, and we're going to make sure we go to the scientific one, desmos.com/scientific, and we're going to say 50 times, here's the cosine button, or you can type in COS, of 63. Now you want to make sure that when you're using it, the degree one is what's showing here. If I change it to radians, saying I want radians, notice it changes the number. We want to make sure that it's in degrees. 22.6995. Does it say what to round to? No. So typically, we're going to round probably to like the nearest hundredth. So 22.70. Okay, but we're setting it up based upon using 63 and that we wanted to find the adjacent side, but the only other information we had was the hypotenuse. So that was x. Now we got to try and find y, right? We got to find y, which we said was the opposite side. So what trig function can we use if 63 is our measure that uses the opposite and the hypotenuse? Well, hopefully the acronym you remember was SO. The sine of our angle, so the sine of the angle in this case was 63, equals the opposite leg, which in this case we don't know, so that's y, over the hypotenuse, which we'll say is 50. How do I get y by itself? Well, I got to undo that 50, so I multiply both sides by 50, and 50 times the sine of 63 equals y. The 50 sine of 63. 50. So if we type it in, 50 times the sine of 63. 44.55 equals y. So if you're unsure of how to set that up or how to go about solving, I can't encourage you enough to make sure that you reach out. Again, you can use your Inspire. Your Inspire should have the sine, cosine, and tangent buttons as well. Make sure you close the parenthesis, after you've put your degree in, so that it's calculating it correctly. All right, let's look at what does this mean in terms of a story problem, okay? A 20-foot ladder is placed 75 degrees with the ground. How high up the wall does the ladder reach? Running into the nearest hundredth. How far from the building is the base of the ladder? Okay, so I'm going to just draw a picture for a second, right? Here's my ladder. We're just going to go 2D. And what we're saying is that this ladder is 20 feet tall, okay? So now if I turn it sideways and we just look at it this way, there's my ladder. But what we're doing is we're taking it and we're leaning it against some wall. So my ladder is leaning against this wall, right? Here's the wall. Here's the ground. The wall and the ground create a right angle. We know the ladder that we decided to lean is 20 feet and that it's 75 degrees at the ground. So knowing how to set this one up is half the battle. Okay? It wants to know how high up the wall, so how high up the wall will it reach? Well, if this is my angle measure, once again, 75 is the angle measure, what side of the triangle is the wall? That's the opposite side once again. And what do we call the ladder in this case? The 20, because it's opposite the right angle, it's our hypotenuse. So which trig function uses opposite and hypotenuse? That is sine. So we're going to do the sine of the 75 degree angle has to equal the opposite, which is the height on the wall, over the hypotenuse. And if we want h by itself, we multiply both sides by 20. And we've got 20 times the sine of 75 equals how far on the wall it is. So again, we're going to go back to Desmos. 20 times the sine of 75. 20 times the sine, The sine of 75 means it's 19.32 feet. 19.32 feet on the wall. Okay. The other one is how far from the base. How far is it from the base of the ladder to the wall? How far is this distance? Well, what side is the distance down here? Oh, that's the adjacent. So what trig function uses this adjacent side that we're looking for? And the hypotenuse, which is the one we've got a number, adjacent hypotenuse, is cosine. Cosine of our angle equals the adjacent side, which we'll call d for distance, over 20, or 20 times the cosine of 75 will have to equal that base distance on the ground. 20 times the cosine. 20 times the cosine of 75 is 5.18. 5.18 feet. So again, half the battle is first knowing how to set up a diagram, but then trying to identify, if they give me a certain angle, what sides are what. All right, now here's the last one. A little bit of a harder example, but it's still manageable if we understand, again, what angle we have and what we're looking for. Okay, finding x, if that's our angle. So what side of the triangle is x on? Well, this is our hypotenuse now. Now we're looking for the hypotenuse. What side of the triangle do they give us if our angle is here? That's the adjacent side. So what trig function uses adjacent and hypotenuse? That's cosine of our angle measure. So cosine of 53 equals the adjacent side, which now is 6, over the hypotenuse, which is now x. And this presents a small dilemma because we haven't done a lot where x is in the denominator. But there's a unique thing that happens, right? To move x, get it out of the denominator, we want to multiply by x. If I do that on one side, I have to do that on the other, which means I have x times the cosine of 53 equals 6. Remember that the cosine of 53 is really some decimal. It's a number, right? And if I have a number with a variable, how do I get rid of that number? We divide by it. And so we really are calculating what is 6 divided by the cosine of 53. 6 divided by the cosine. 6 divided by the cosine of, now I forgot the degree measure, 53. So I'm going to go back over here, make sure that I'm in the right spot, 53, and we get 9.97. 9.97 for that hypotenuse. So again, I hope you see that it's a lot of repetition and skill work, but it's understanding how to label the sides of a right triangle based on where the angle is positioned. Can you label it correctly? And then once you've labeled it, do you know which one of those three, so, ka, toa, which one of those three are you using to try and find that missing piece? If you have questions, you got to make sure that you reach out. You got to make sure that you holler and let me know that something just isn't making sense. Make sure you try the practice problems today. Have a good weekend, and until next time, stay safe.